Now, how many of you were able to do it? පුළුවන් වුණාද? So we have the governing equation x double dot plus omega n squared x equals 0, and we have given the solution, and also we have the initial condition x naught and x dot naught, both are given, and the general format of the solution is x equals a sine omega n t plus b cos omega n t, right? Then this is the given solution, right? So we can find the velocity x dot. What we have to do is differentiate this solution one time. So what we have, a omega n, and the differentiation of sine is what? It is cos. Cos omega n t plus b, again the same thing, omega n, and this time differentiation of cos is minus sine. Right? And then we can find the acceleration using the same thing, differentiate the velocity again with time. And this time we will have a, and we have omega n here, omega n squared. This is cos, that means we have a minus sine omega n t minus b omega n squared cos
සර් අපිට සර් කියන එක ඇහෙන්නේ නැහැ නේ සර්.
දැන් හරිද? මම හිතනවා මගේ mute වෙලා තිබිලා. Right? So what we're going to do, since the equation for displacement is valid for any t value, it should hold for t equals 0. Right? So we are going to put t equals 0 and find what is the value for displacement. So x0 is a, and sine omega nt, t is 0, becomes 0, and b into cos omega nt, cos 0 is 1, so it is b into 1. That means b is how much? It is x naught, right? Then in the same way, this is the velocity equation, and at any time t, this is true, so it should hold for x equals t equals 0. So let's find x dot 0. We have a omega n. This is cos omega nt. That means this part is 1. Minus, you have a sine term here, and sine 0 is 0. So from here, what we get? X dot 0 is equal to a omega n. Then we can find this constant a as x dot 0 initial velocity divided by omega n natural frequency as this capital A, right? Then we have the complete solution for this system. We have x equals a is x dot at 0 divided by natural frequency sine omega nt plus b is x naught cos omega n t. Hari? Then how you convert this one into that final format? X equals a cos or sine is much easy. Sine omega nt plus phi.
Sir, we can't see the paper, sir.
Paper එක ඕනේ නැහැ තනියෙන් හදන්න පුළුවන්. Now what to do? Convert this one into this format. මොකද කරන්නේ? So you have addition of sine function and a cos function. And we need to get one single sine function. What are you going to do? Now these parts, again, you have to use the knowledge in advanced level. Since you have sine and cosine function here, and it end up as one single sine function, මොකක්ද එකෙන් කියන්නේ? මේක නිකන් හරියට මෙහෙම එකක් නෙමෙයිද? Sin a plus b equals what? මොකක්ද identity එක? a plus b expand කරාම. මේක දන්නේ නැහැ කියන්න එපා.
Sin A cos B plus cos A sin B.
Sin a cos b plus cos a sin b. Right? So when you look at that, this equation, sin a is this part. It is there. Right? And here, cos a is this part. That means we have to convert these two terms, this one to cos b and this one to sin b. කොහොමද ඒක කරන්නේ? මොකද කරන්නේ? Take this term as cos phi and this term as sin phi. මෙහෙම කරන්න පුළුවන්ද? මේ වැඩේ හරිද වැරදිද? ඔය වැඩේ කරපු ගමන් මේක හරි. Now the question is are we allowed to do this? The nice thing is that both these sine and cos are real functions, right? So the values, they can take many different formats. Actually, they are representing some ratio, right? So if we have a triangle with this side as how much? This is angle phi. If this is x dot naught over omega n, and this side as
සර් පොඩ්ඩක් කොලේ උස්සනවද?
ඔය ඕනේද මේවා ලියා ගන්න. You know these things from very early stages. And this part is how much? The addition of squares of this one, right? So again, everything is constants. So you can manipulate this into this format, right? So it is allowed you to do it. Actually, you will get some constant that's okay. Anyway, we have constants, right? Then once you have that, we end up with x. Since we have this additional term, which is how much? X dot naught over omega n, all things squared, plus x naught squared, right? So I'm going to take it to out. And inside we have sine omega n t cos phi plus cos omega n t sine phi, right? Now it simplifies into this one. Sine omega n t plus, and this is a constant. X naught dot is the initial condition which is given. X naught is the initial displacement which is given. They are not going to change. And this is natural frequency. Again, it is a property of the system, not going to change. That means this whole thing, we can take it as a constant. And from this one, you directly get what is A is. A is square root of x naught dot over omega n square plus x naught square. Right? And what is phi? Is tan inverse from here x naught divided by x dot naught over omega n. This is the complete solution. And when you do that, you automatically get what this constant A and what is constant phi. Any questions? ඔක්කොම දන්නවා වගේ ඉන්න එපා. එක්සෑම් එකට ගියාම හොඳ පිස්සු නටනවා කට්ටිය. Is there anything you want to ask? No. Right. So this is the complete solution for free undamped vibrations. Right. Now we need to look at some simple terms or terminologies that we come across when you want to do vibrations. One of them we already discussed, omega n. This is the natural frequency and already you know what it is. Right? There's another one. Simple. What is this one? F කියන්නේ මොකක්ද? What is simple F? And another important term is there, capital T. Now, capital T, at least we know what it is. It is the time taken for one complete cycle. Right? Since we have a sine function as the answer, that means the time it needs to complete one sine function. Right? So this one we can find as what? Omega n is called as natural frequency, and there's another name for that one. අනිත් නම් මොකක්ද? Angular frequency. Right? That means this capital T or the period is really, we know that one cycle is 2π, that is the total angle, and the speed is how much? Omega n. Then what is this simple f? We simply called as frequency. This represents the number of complete cycles per unit time. That means we know that for one cycle, it takes time of capital T. So per 1 second, how many full cycles are there? Right? So that means F is 1 over T. Or from this one, omega n over 2π. And what are the units? Omega n is measured with what? Radian per second. T is measured in seconds. And this F is measured in what? Frequency. We have a special unit for that one, hertz. Right? Any questions? Okay, then do the second part. K, M. This is the direction we measure displacement. In addition to, you have F naught sine omega naught t. A very simple harmonic external force. We simply call them as harmonic exciters. Right? This happens a lot in the mechanical vibrations. Right? Most of the time we have cyclic things. So they give rise to vibrations, cyclic vibrations, and the forces also in cyclic nature. Right? Very simplest example is vehicle engine. Right? You have a lot of cyclic processes going in with that one. So it is pretty much similar to this kind of situation. Now find the complete solution for this case. Did you find the solution? So what is the governing equation for this case? X double dot KOM X equals F naught of M sine omega naught T. Right? And as we discussed, this is non-homogeneous. That means we have two parts in the solution. Right? X is XH, which is the homogeneous part, plus the particular integral x p. Right? This part we already found. It is same as the previous case. Right? Except you have. So what we really need is this xp term. And this one, there's no exact answer. Only thing, you have to assume a solution and check whether it is going to validate with your governing equation. Right? That is also one way to solve differential equations. Now, how can you assume a solution? On what basis? කොහොමද හිතන්නේ මේක මේ විදිහේ උත්තරයක් වෙන්න ඕනේ කියලා? Now, what you have to look here is that the given system is vibrating. That means it is a cyclic system. The solution for the homogeneous part, that also a periodic function. Sine term is there, right? And when you look at the forcing function, it is also a periodic function. So we can safely assume that whatever the particular integral should be a periodic function, right? And since this particular integral is the only thing which changes the force system from the free system, right? There, it is the only place where you have this external force term coming in. So we can assume whatever this particular integral is, it should have a periodic function which is similar to the external force, right? All assumptions, we have to check whether they are correct or not by checking this solution with the governing equation. Right? So let's assume xp as a constant. This is a typical notation, capital X. So try to use the same thing because then it will be easier when you go for the next sections into sine omega naught, right? So if this is a solution, it must fulfill the governing equation, right? So use this one and put it in the governing equation and find this particular integral in this format. So I'm not going to do the whole simplification. You have to do it on your own. Can you do it on your own? You need any help? Now this one you can do on your own. There is nothing in here. Just manipulating the terms here and there. So first find x dot and x double dot. How much is x dot? This is our particular integral. So x dot p and x double dot p. This will be x omega naught cos omega naught t, and this one x omega naught squared minus sine omega naught t. Right? Then this is the governing equation. This is the solution. So it must fulfill this one. Minus x omega naught squared sine omega naught t plus k over m x sine omega naught t equals f naught over m sine omega naught t. Right? So sine omega naught t is there in every term. So we have k, not x. K over n is what? Omega n squared. we have omega n squared minus omega naught squared equals f naught over m. Then I am going to divide this one with omega n squared. Right? When I do that, 1 minus since I divide it, we have to multiply it at the outside, omega n squared. Then this one is k over m. M is there in both sides. So you can remove m and we find this amplitude of the particular integral as f naught over k divided by 1 minus omega naught squared over omega n squared. And now we can write the full solution. Our solution is x is equal to a sine omega n t plus phi plus f naught over k 1 minus omega naught squared omega n squared into sine omega naught t. Right, so this is the total solution. Now when you look at this solution, we can come up with some properties of this particular undamped forced vibration systems. Now you can clearly see that this equation of the motion is governed by two different sign functions, right? There is sign function which depends on the natural frequency of the system, which is a property of the system, and there's another sign function which depends on the frequency of the external force. So this is the external thing, right? This is something in system itself. This is something coming from the external force. And here is a very interesting part is there. What happens if omega naught is very close to omega n? Now what will happen? Can you explain by looking into this equation? මොකද වෙන්නේ? Yes, ප්‍රසාදිකා මොකද වෙන්නේ? What happened? When the natural frequency of the system and the frequency of the forcing function are very close to one another. What happens? You can explain by looking at this equation of motion.
resonance වෙනවා.
Huh?
resonance වෙනවා.
Resonance. Why it called as the resonance? So what happens at that particular point?
failures ඇති වෙන්න පුළුවන්.
Huh? දැන් මං අහන්නේ මේ equation එකෙන් මොකද වෙන්නේ කියලා කියන්න පුළුවන්ද? You have to explain it looking at the equation. What kind of things that you can
cancel out වෙනවා මේ term එකම.
මොන term එකද? Cancel out වෙන්නේ කොහොමද term එක? When you have omega naught and omega n very close to each other, what happened to this ratio? Omega naught or omega n? Huh? They are very close to what?
1.
Huh?
1.
They are close to 1, yes. Then what happened to this?
Second part doesn't exist.
Huh? This
Atta,
part goes very near to 0. Right? If that is going to be near 0, what happened to this whole term?
doesn't exist.
Doesn't exist, නෙමෙයි. It is going near 0. It is not equal to 0. I didn't say these are exactly equal. Then what will happen? When it becomes smaller and smaller,
whole
the
term
whole
going
term
to 0.
becomes the whole term is going to reach infinity. So what will happen? These two are the amplitudes. That means when you have these two frequencies close to each other, you are going to get higher and higher amplitudes. That is called as the resonance. Right? You have increasing amplitudes with time. In actual systems, can you have that in that way?
yes.
Increased? Huh?
yes sir.
Yes. Vibrations amplitude going to increase each and every step. මොකක්ද වෙන්න ඕනේ එතකොට? If you have it in this way.
damping
Huh? Damping නෑ නෙමෙයි.
වෙනවා.
There is no damp. So remember that if you have resonance in free vibrations, undamped vibration, your system is going to crash after few steps. හරි මොකේකටවත් බෑ ඇම්ප්ලිටියුඩ් එක වැඩි වෙන්න ඒ තරමට එහා මෙහා වෙන්න. එක්ක ස්ප්‍රින්ග් එක කැඩෙයි. Right? That is what it means. You are having infinite displacement, which is not possible. Right? So resonance cannot happen and sustain the motion with undamped vibrations. Right? If there is no damping, you cannot allow resonance to happen. It will destroy your system. Right? Any questions? If not, we can stop here. It is raining heavily outside and also some thundering. Any questions you want to ask?